Hi students, welcome to Roots Academy. Myself Inayatullah, lecturer of mathematics. Student, in our today's video, we will discuss about the continuity of a function. So we will discuss the fifth chapter of second PUC, that is continuity and differentiability. In that we will first discuss continuity. Very interesting topic it is. Definitely they will ask one question for 4 marks in second PUC annual examination. So student, first, before we go to problems, let us understand the concepts and the meaning and definition of continuity. Student, if you want to understand the continuity meaning or definition, first we should have a knowledge of limits. Student, in our first PUC, we studied limits in detail. So student, there are two kinds of limits here. So one is left hand limit. It is represented by limit x tends to a power minus f of x. So student, left hand limit means value of x approaching towards the left hand side. Towards the left hand side. That is represented as left hand limit. Suppose if I have a number line here, there is a 0 and there is a 1 here and there is a 2 here. So here, if I fix the condition for x as 1, then from the left hand side of this one, a value is coming. So that is left hand limit. And in limit concepts in the first PUC, we studied very much clearly about limits, so I am not going in detail of limit. Let me explain what is this representation called as. This representation says that the value of x is approaching towards a from the left hand side, but it will never be equal to this value. The value of x will never be equal to this. It is just moving towards a. Suppose if I take here 1, x will never be equal to 1, but approximately it is equals to 1. So what will be the nearer value of this is 0.9999, very closer to 1. So this is the representation of left hand limit. Next is right hand limit, RHL. It is, in short, we can call it as RHL, right hand limit. So its representation is limit x tends to a power plus f of x. Here it is plus. Means whatever the value we have taken here, we will take little bit greater value of that. The moment I said it is, we will take little bit greater value, but approximately equals to this, then it is called as the value is coming from the right hand side. If I stick to 1, then the value of x is approaching towards 1 from the right hand side. From the right hand side. Then what will be the value from the right hand side? 1.001. In left hand limit it is 0.9999 and in right hand side it is 1.0001. So student, these are the representations of right hand limit and left hand limit. Now student, let us come to the general meaning of continuity. Student, if you want to just understand what is continuity is, if we draw the graph of any function, if we are drawing the graph of any kind of function, if the graph is plotting without lifting our pen, if we are able to draw the graph of any function without lifting our pen, then those functions are called as continuous functions. If suppose if anywhere we are lifting our pen, anywhere the graph is disturbed or it is jumped, then that particular functions are discontinuous. So for example, we'll take some example. Every parabola graph, we can plot as big the parabola as much we can, so without lifting a pen. So parabola graphs are continuous graphs. Then next is modulus graphs, V-shaped graphs are a continuous graph. Then circles and etc. etc. But when it comes to the signum function graph, when it comes to signum function graph, when I take x as 0, then it is 0. The moment when I take x as 1, then I should lift my pen and I should mark as 1. The moment if I take 2, I should mark as again 1. Then it is like this, it continues. For every value of x which is greater than 0, it is 1. But here from 0 to 1, I jumped. There is no continuity here. Same way, if I take any negative value, then the value will be -1. So again, there is a gap here. So here I lifted my pen to draw this graph. You might have seen. First I draw this line, then circle, then this line. So here it is discontinuous function. So like signum graph and step function graph, those are discontinuous functions. But whereas parabola graph, modulus graph and circles and other graphs are continuous functions. So just this is the meaning of continuity. Now let us comes to the definition of continuity. So student, here I explained the concepts of left hand limit and right hand limit. So here the definition, I will come to the definition now. Definition of continuity of a function. So if you want to prove any function is continuous, then we will just check three things. What are the three things? First, we should check f. Suppose y is equals to f of x in any function. Then this function I should check at x is equals to a. I should find the value of this function at x is equals to a. If the value is, okay, let us take later. Then second thing, I should find left hand limit of this function. I should find the left hand limit of this function. As I said, we should take the value of x from the left hand side. Third, we should find the right hand limit of the function. So after finding these three things, if all these three values are equal, then we can declare that the given function is a continuous function. So that is f of a is equals to left hand limit that is equals to right hand limit. Now if these three are equal to any function, then we will declare that particular function is a continuous function. If any one is different, then we will declare that the given function is discontinuous at that particular point. So this is about the definition and meaning of continuity of function. Now student, if any problem of a continuity of function or continuity or discontinuity, to take left hand limit, we will prefer the lesser values of x. If suppose x has less than a, then whenever we will get this kind of conditions that x is lesser than the value, those functions, whatever the functions related to this condition, that function is called as left hand limit function. For right hand limit, we will not take the same function. For right hand limit, we will take the function whose condition is x greater than a, where a is any value. If this condition comes, then whatever the function is related to this condition, that function we will take for right hand limit. For those two different functions, if the values are equals to f of a, then we will declare that it is continuous. Otherwise, it is not continuous. So, student, if you want to take left hand limit function, we will check this condition for left hand limit, and for right hand limit, we will check this condition. If anywhere comes equals, then that is considered as equals to, that is f of a. Okay, students, now let us solve some problems. Very basic problems we'll take. First one is, examine the continuity of the function f of x is equals to 5x plus 3 at x is equals to 3. Student, here just we should check the continuity of the function, but here there is no condition for x. There is no less than or greater than. He has directly taken x is equals to 3. So now let us not go for left hand or right hand limit. Directly we can take limit as well as x is equal to this. Solution. Given f of x is equals to 5x plus 3. F of x is equals to 5x plus 3. Now, at x is equals to 3, which implies f of 3 is equals to 5 into 3 plus 3. So how much it is? 5 into 3 is 15 plus 3. This is equals to 18. F of 3 is 18. Next, let us take the limit. Since he has not given any condition, that is less than or greater than condition is not there here, so we'll take directly limit. Limit x tends to a f of x, that is equals to limit x tends to 3 f of x value is 5x plus 3. Now student, here as I said, the value of x is approaching towards 3, but it will never be equal to 3. But in the other way, approximately equal to 3 it is. So here in this case, I will directly substitute x as 3 only, because anyway it is approximately equal to 3. To save our time, let us directly put x as 3 here. So 5 into 3 plus 3, so here it is 18. Now student, here we can easily see that f of 3 is same as the limit of the function at x is equal to 3. Therefore, f of 3 is equals to limit x tends to 3 f of x. Hence, the given function is continuous. And the given function is continuous because these two values are equal. Okay, students, now let us go to the next problem. examine the continuity of function f of x is equals to 2x cube minus 1 at x is equals to 2. Same method, since I have not given less than or greater than condition, I have directly taken x is equals to 2. So, solution given f of x is equals to 2x cube minus 1 at x is equals to 2, the function becomes 2 into 2 cube minus 1. 2 into 2 cube minus 1. So this is equals to 2 into 8 minus 1. 16 minus 1, it is 15. 16 minus 1, it is 15. Next, limit x tends to 2, sorry, again, f of x is equals to limit x tends to 2x cube minus 1. So 2 into 2 cube minus 1 is 15. So here I substituted x as 2. So 2 cube is 8 into 2 16 minus 1 it is 15. So student, here both are equal. Therefore f of 2 is equals to limit x tends to 2 f of x, hence the given function is continuous, because these two values are exactly equal, so we can declare that the given function is continuous at x is equals to 2. Okay students, now we will go to the next step of the problems, which are very, very important. Definitely they will ask this kind of problems for 4 marks in our annual examination. So let us start now. That is, find all points of discontinuity of the function f of x is equals to f of x is equals to 2x plus 3 if x less than or equals to 2, 2x minus 3 if x greater than 2. Okay student, in this problem he is asking us to find all points of discontinuity where at x is equals to 2, because the condition for x is 2 here. So here there is a left hand as well as right hand limit, so we must use left hand and right hand concept. Two different functions, one is for left hand limit, other is for right hand limit, and equals also same function. So student, if f of a and left hand limit and right hand limit, if these three are different, then we will declare that the given function is discontinuous at x is equal to 2. But if all the three are equal at x is equals to 2, we will declare that there is no point of discontinuity at x is equals to 2. So let us start this. Solution: given f of x is equals to 2x plus 3 if x less than or equal to 2, 2x minus 3 if x greater than 2. First, when x is equals to 2, if I take x as directly 2, then what happened to the function? So student, here when I am taking x is directly equals to 2, then see there is the equality sign here in the first condition. So at that time, for me the function is this one. I cannot take this as the function because here there is no equality sign. There is the equality sign here, so I must take this is the function when x is exactly equals to 2. So f of x is equals to 2x plus 3. Put x is equals to 2. So f of 2 is equals to 2 into 2 plus 3. It is 4 plus 3. It is 7. So f of 2 is 7. Okay. Next, let us take left hand limit. Limit extends to a power minus f of x. Its choice is ours. It is not necessary that we should first find left hand limit or we should first find right hand limit only. Both we should find. Whichever we feel comfortable, that we can do first. But we must do left hand as well as right hand both. This is equals to limit extends to 2 minus. The value of a is 2 here because the condition is 2. What is the function for left hand limit? This itself is the function for left hand limit because here less than is there. X is lesser compared to 2. So it is 2x plus 3. Finally, if we directly substitute x as 2 here, so 2 into 2 plus 3, this is again 7. Next, right hand limit. Limit extends to a power plus f of x. This is equals to limit extends to 2 power plus, what is this? F of x here? Greater value of x. This condition declares that the value of x is greater than 2 here. So this is our right hand limit function. That is 2x minus 3. So here if I substitute the value of x as 2, 2 into 2 minus 3. So here 2 into 2 is 4 minus 3, it's 1. So here left hand limit is not equals with right hand limit. So limit does not exist here. Therefore, f of 2 is equals to left hand limit, but this is not equals to right hand limit. So student, in this case, the given function has discontinuity at x is equals to 2. The given function has discontinuity at x is equals to 2 because these two are not equal. If all the three are equal, then it is the continuous at x is equals to 2. So this much, if you write, you will get 4 marks, and definitely one problem similar to this or based on this topic, they will definitely ask. I hope people understand this. Okay, students, now let us go to the next problem. Find all points of discontinuity of function f of x is equals to x cube minus 3 if x less than or equals to 2, x square plus 1 if x greater than 2. Okay, student? Here again two functions are given. One is less for x less than or equals to, another is for x greater than 2. That means this is our left hand limit function as well as this is our equals to 2 function. For right hand limit function, the function is x square plus 1. Solution. Given f of x is equals to x cube minus 3 if x is less than or equals to 2, x square plus 1 if x greater than 2. When x is equals to 2, f of x is equals to x cube minus 3. The moment I say x is equals to 2, then my function is x cube minus 3. I've taken x cube minus 3. We should put x is equals to 2 here. Put x is equals to 2 in this function. So then it becomes f of 2, 2 cube minus 3. 2 cube is 8, 8 minus 3, it is 5. So next time, left hand limits. Limit x tends to a power minus f of x. So this is equals to limit x tends to 2 power minus, what is f of x here? Here f of x is x cube minus 3. X is less than 2. This is the condition and the function for this condition is x cube minus 3. Now let us directly substitute x as 2. This becomes 2 cube minus 3. So that is 5. Because 2 cube is 8. 8 minus 3 is 5. Next is right hand limit. Limit x tends to a power plus f of x is equals to limit x tends to 2 plus, for right hand limit student, this is the condition for right hand limit and the function is this x square plus 1 that is equals to 2 square plus 1, it is 5. 2 square is 4, 4 plus 1 is 5. Now student, in this problem we can just see here f of 2 is 5, left hand limit is 5 and my right hand limit is 5. All the three values are equal. Since f of 2 is equals to left hand limit, this is equals to right hand limit. The given function is continuous at x is equals to 2. It's not discontinuous. This function is continuous because all three are equal at x is equals to 2. Students, now let us go to the next problem. In this problem also we will find all points of discontinuity. Students, this time it has given three functions and two different conditions of x. You can just see here, there are two different values for x here. Here there is a -3, -3, +3 and +3. So for -3, there is a left hand limit as well as right hand limit. And again for +3, there is a left hand limit as well as right hand limit here. So students, when we will give this kind of problems, we will first take the first condition of x. First we should find all the three things for the first condition of x. That is the first value of x. After finally finishing that, we should take the next value of x. Again we should do same three things. F of a, left hand limit, right hand limit. Now this function is a little special function, very special function. The reason here is there is a mod here. Because of mod, this function becomes a very special function to us. Why I am calling this as a special function? Student, we know that in mod there are two functions. One is a positive value, other is a negative value. And the positive value is for those who are greater than 0. And the negative value for those which are lesser than 0. But student, here I have the value of x is lesser, less than -3, lesser values I need. The moment I said the values of x are lesser, then this mod x becomes -x. This mod x becomes -x. Because mod x has two different functions. The definition of mod x. Positive x if x is greater than 0. Negative x if x is less than 0. So here I should take -x because x is less than. So I will write the proper function now. Solution. Given f of x is equals to -x plus 3 if if x less than or equals to -3, other things are same. If -3 less than x less than 3, 6x plus 2 if x greater than or equal to 3. First, when x is equals to -3, let us see what happens when x is equals to -3. Whether it is continuous or discontinuous. F of x is equals to -3 and there is the equality sign. So function is this -x plus 3. Put x is equals to -3. Then the function becomes f of -3 is equals to minus of -3 plus 3. It is 6. Minus into minus, it is plus 3 plus 3 is 6. Left hand limit. Limit extends to a minus f of x. This is equals to limit extends to -3 minus left hand limit function, student. The value of x is lesser here. So this itself is a function -x plus 3 that is equals to minus of -3 plus 3. It is 6. Next, right hand limit. So limit extends to a plus f of x is equals to limit extends to minus 3 plus. Now student, for minus 3 we should take right hand limit function. Listen carefully here. Minus 3 is less than x. Student here, minus 3 is lesser compared to x. Means x value is greater than minus 3. So this is the right hand limit function when x is minus 3. So it is minus 2 into x. Minus 2 into minus 3 is 6. So you can see here all the three values are equal. Since f of minus 3 is equals to left hand limit is equals to right hand limit, the given function is continuous at x is equals to minus 3. So at this stage we have completed the 50% of the problem, that is for one condition of x. Now same thing we should do for the another condition of x, that is another value of x. The value is 3 here. So now let us check when x is equals to plus 3 now. When x is equals to plus 3, f of x is equals to, so the moment I said x is equals to 3, now the functions will change. At any cost, this function will not come now. This will not come. This is over. This is only for x is equal, x less than or equal to minus 3. Now, when I said x is equals to 3, here is the equality sign, and x is 3. And the function is 6x plus 2. So here 6x plus 2 is the function. Now in this function, I should put x as 3. Put x is equals to 3. So this becomes f of 3 is equals to 6 into 3 plus 2, 18 plus 2, student, it is 20. So f of 3 is equals to 20 here. Let us check what is our left hand limit. So left hand limit is equals to limit x tends to a power minus f of x. This is equals to limit x tends to 3 power minus, what is f of x here? Here x less than 3. So this is the left hand limit function, and when x is equals to 3, then left hand limit function is minus 2x. Minus 2 into x, that is minus 2 into 3, answer is minus 6. And so here you can see that f of 3 is 20, left hand limit is minus 6. Already we got different value, but it's better we will do right hand limit also. So right hand limit is equals to limit x tends to a power plus f of x. This is equals to limit x tends to 3 power plus. Now for right hand limit, there is a function x greater than 3, and the function is 6x plus 2. So 6 into 3 plus 2, 18 plus 2, it is 20. Now students, here we can check the values are different. All three are not equal. So this function is not continuous at x is equals to 3. Since f of 3 is not equals to left hand limit, and this left hand limit is not equals to right hand limit, the given function is discontinuous at x is equals to 3. Here there are two conditions for x. First condition was -3. There it is continuous. Now when I took x is equals to 3, that is the second condition. Second condition, at this time the function is discontinuous. Problem: find the relationship between A and B so that the function f of x is equals to ax plus 1 if x less than or equals to 3, bx plus 3 if x greater than 3 is continuous and x is equals. Okay, students. Students, isn't it? Student, in this problem, he is asking us to find the relationship between A and B. A and B are two constants. We should find the relationship between these two values. Where the function is this, he has given left hand limit and right hand limit here, and that equals to also. And now, student, in this problem, he himself has declared that it is a continuous function and x is equals to 3. We no need to worry that what is left hand limit, what is right hand limit, what is our f of 3. Whatever those values are, we should consider it is equal. With the help of those consideration, we should find the relationship between these two things. Okay, let us see how is it possible. Given f of x is equals to ax plus 1 if x is less than or equals to 3, bx plus 3 if x greater than 3. Okay. When x is equals to 3, when I said the value of x is 3, then the function will be f of x is equals to ax plus 1. Now put x is equals to 3. That implies f of 3 is equals to a into 3 plus 1, that is 3a plus 1. Next, left hand limit. Limit extends to a minus f of x. This is equals to limit extends to 3 power minus left hand limit. And x is less than 3 here. So this is the condition for less left hand limit. And the function is this. Ax plus 1, that is 3a plus 1. Next, right hand limit. Limit extends to a plus f of x. This is equals to limit extends to 3 power plus dx plus 3. So that is equals to 3b plus 3. So you can just see here, these two are equal, but this is not equal. But still, since he himself declared that it is a continuous, so let us take all these three are equal. Since the function is continuous at x is equals to 3, that is f of 3 is equals to left hand limit is equals to right hand limit. Instead of taking three things equal, I will take two different things are equal. 3a plus 1, this is equals with 3b plus 3. Since he is asking us to find the relationship between these two values, let me try to find a or b in terms of some other variable. We should find a in terms of b, or b we should find in terms of a. So that is equals to 3a is equals to 3b plus 3 minus 1. This plus 1 I shifted to other side. If you want, you can shift plus 3 also. So you can find b value. If you are finding b value, you will get answer in terms of a. Here I am finding the value of a in terms of b. So I shifted plus 1 to other side. So my 3a is equals to 3b plus 2. So finally, my a value will be 3b plus 2 divided by 3. So student, this is the relation between a and b. Student, I hope you people understand the concepts of continuity. If you have any doubt in today's topic, you can put your doubt in comment box. And if you are new to our channel, don't forget to subscribe. So student, to help the other students, keep sharing our videos so others can be benefited with this. Thank you, student.